Hello all, let's start section 2.6. 2.6, we are talking still on functions, more on functions. Here we talk about combinations of functions and also composite function or composition of functions. Before moving to combination, let's discuss the domain of a function again, correct? The domain of functions. Here, I'll discuss three types of functions with you. The first one, polynomial functions. I will discuss the domain of rational functions. And also square root. The domain of square root functions, correct? I think the last one is a square root. Let me check here, yeah. It should be the square root functions. Yeah, square root. The domain of the square root functions. Correct? Let's start with the domain of polynomial functions. Polynomials or polynomial functions. The domain of polynomial functions, their domain, is always from negative infinity to positive infinity. The domain of polynomial functions, any polynomial functions that you are talking about, their domain is the same. The domain is from negative infinity to where? To positive infinity. I will not discuss again what is polynomial because I already explained to you in one of my videos what is polynomial, correct? For example, if I have f of x equals 2x squared plus 5x minus 4, if someone asks me what is the domain of this function, immediately from negative infinity to positive infinity, correct? Or if I have f of x equals 2x plus 1, what is, because it's also a polynomial function, what is the domain of this function? The domain is from negative infinity to positive infinity, correct? Domain is the same for all of them, negative infinity to positive infinity. Now, the second type, rational functions, correct? Rational functions. If I have a rational function, for example, f of x equals x minus 3 over x squared minus 25, right? We call this type of functions rational functions because I already discussed with you what are the rational expressions, right? Any expression that you have a variable in the denominator, you call it rational. Then any function that has a variable in the denominator, like this, here x squared, we call it a rational function. Now, how you will find the domain of a rational function? You know that there is a value of x here that if you plug in to the denominator, it changes the denominator to 0, correct? For example, in this one, it's easy, I know. If I plug in 5 and x, 5 squared gives me 25, and 25 minus 25 gives me 0. And the top, I have x minus 3, correct? When your denominator is 0, we call it undefined, right? It means 5 is not in the domain of this function, because if I put 5 in the domain of this function, then my function, the domain, becomes undefined. Now, what we do, I explained here for you this way. Now look at the actual explanation. Whenever you are dealing with a rational function, immediately set the denominator, whatever the denominator is. Here my denominator is x squared minus 25. Set it equal to 0. Or even in some books, we say this, the denominator cannot be 0. Correct? The denominator cannot be 0. Solve it. Correct? Solve this. If you solve this, you see, you can factor, or you can use the square root property. Which way you go, it's up to you. I will factor it. X minus 5 times x plus 5 equal cannot be 0, correct? Then x minus 5 cannot be 0, equal to 0. It means x cannot be equal to 5. And also, x plus 5 cannot be equal to 0. It means x cannot be equal to negative 5. Actually, these two values that you find here, these are your restrictions, correct? When you are dealing with functions, we call these two values the vertical asymptotes. This one is a vertical asymptote, and this one is a vertical asymptote. Okay? Later, when we go to graph these functions, I will explain to you what does it mean on that time. What is a vertical asymptote? We will discuss it more, correct? But for time being, these two values, x cannot take these two values. Now, how to write the domain? Number line is helping you a lot to write your domain. I know many people, they don't explain it this way, but I like to explain it this way. Here, 0, for example, here, plug 5, and here mark it as a negative 5. Your function cannot take 5, negative 5, and any other number that you plug in the denominator, it's okay. Only negative 5 and 5 changes the denominator to 0. That's why I opened, I used an open circle here, correct? Now, x can take these values. X can take also these values between negative 5 and 5, and also x can take these values from 5 to infinity, correct? Here infinity, here negative infinity. Now, isn't it easy now to write the domain? Then I can write the domain as, for negative infinity, you are using parentheses. From negative infinity to where? To negative 5. For open circle, we are using parentheses, correct? Now, the second part starts from negative 5 to 5, again parentheses. And the third part starts from 5 to infinity. To connect all these as a one domain, we use the union symbol. We connect them with what? With union. That is the exact way that you are writing your domain, correct? The domain is of this function is from negative infinity to negative 5, from negative 5 to 5, and from 5 to infinity. Or the other way, if you use the set notation, the domain will be all values of x, then draw a line here. We read this line such that the domain of this function is all values of x such that x cannot take 5 and x cannot take negative 5. Correct? That will be the domain of this function if you want to write it in set notation. I know this type, we are not using it a lot. Usually try to write your domain in this way. I will accept this way. And I like to write my domain always like this. Correct? Because for some people, the set notation is a little bit difficult to write. Another example. Example number 2. For example, I have g of x equals 3x plus 2 over x squared minus 2x minus 3. To find the domain, first, even you can do it here, factor the denominator. 3x plus 2. If you can factor the numerator, do it. But we don't need, only we factor because if we can cancel, we can cancel. But if you cannot factor, leave it that way, correct? What are the factors of denominator here? Of course, x and x. Two numbers to multiply gives you negative 3. To add gives you negative 2. Of course, negative 3 plus what? 1. Now, to write the domain, first find the restrictions. It means set the denominator, which is x minus 3 times x plus 1 equal to 0. Or use this sign, which way you use. Correct? X minus 3 cannot be equal to 0. It means x cannot be equal to 3. X plus 1 cannot be equal to 0. It means x cannot be negative 1. These are my restrictions, correct? Or this, or you can say this two number is not in the domain of this function. Now, draw your number line quickly. To do not forget sometimes infinity and negative infinity, always try to write positive infinity and negative infinity here and mark somewhere as a 0. What are the restrictions? Negative 1 and, for example, here mark it as a 3. Put an open circle around it because you cannot take these numbers, right? Now it's easy to write the domain. The domain will be from where? You can take all these values from negative infinity to negative 1. Then parentheses, negative infinity to negative 1. Correct? Union from negative 1 to where? To 3. Union from 3 to positive infinity. That will be the domain of this rational function. The third type, square root. For example, if I have f of x equals the square root of, let's say, x plus 2. The square root functions also has a restriction. Why? Look, if I have x plus 2, right? If I plug in x, for example, negative 4 here, what will happen? Negative 4 plus 2 gives you the square root of negative 2. The square root of negative 2 will be an imaginary number. It will be I, whatever I is, 0 point something or 1 point something, correct? It means when you have a negative number under the square root, you cannot show it on the number line. It's imaginary. The square root is imaginary, not real. Then the square root of the domain of a square root should have a restriction. Which number or which numbers are changing the value under the square root to a negative? Those are our restrictions, correct? How to find? This is the technique. Write x plus 2. X plus 2 always should be greater or equal to 0, because we know the square root of 0 is 0. We don't have problem. We don't have problem with positive numbers. The only problem is with negative numbers, correct? Then the restriction, whenever you find the restriction for a square root function, set the under the square root, whatever the expression is under the square root, greater equal to 0, correct? And solve. To show you how to solve, I know everyone knows how to solve. Subtract 2 from both sides, correct? Then x should be greater equal than what? Negative 2, correct? Now, number line, mark somewhere as a negative 2. Greater equal, for greater equal, you use a closed circle, correct? Greater equal negative 2 is, of course, the right side, correct? X can take all these values from starting from negative 2 to where? To infinity. Then my domain will be, for closed circle, you are using a bracket, right? Bracket, negative 2, comma, infinity, parentheses. That will be the domain of this function. Let me do one more example for you. G of x equals square root of 2x, let's say, minus 6. Find the domain. Correct? To find the domain, what I do, whatever the expression is under the square root, I'll copy that one to x minus 6, and I'll set equal, greater equal to 0. And I will solve. First, add 6 to both sides. These two cancels out. 2x greater equal 6 divide by 2. X will be greater equal 3. Now, this number is your restriction. All values of x greater than 3. If this point is 3, I will use a closed circle, infinity. After practicing with few problems, even you don't need to draw the number line. But always, to make sure that you are avoiding mistake, I'll recommend you to draw the number line and copy the domain from there. But if you know from here how to write, the domain, no need for number line, correct? Then bracket 3, comma, infinity, parentheses, this is my domain. One more example that a lot of students are doing mistake with this example. Focus here. F of x equals, I'll take a very simple one, a square root of, let's say, 8 minus 4x. Let's find the domain. 8 minus 4x greater equal to 0. Now subtract 8 from both sides. These two cancels out. Negative 4x greater equal negative 8. Now divide both sides by negative 4. These two cancels out. Then you can say x greater equal 2. This is how sometimes we do. I did it on purpose. We don't focus and we write our domain, oh, bracket 2 to infinity. Look, what is my mistake here? I divide both sides of an inequality with negative number. Then I have to flip the inequality sign, correct? X less than 2, less than equal to. This is the mistake that I see a lot. That some students are doing. They don't focus that they are dealing with inequality, correct? If you divide both sides of an inequality or multiply it with negative number, please flip the sign or the symbol. Now, number line, here is 2, close circle, less than 2. It means all these values, correct? To where? To negative infinity. Then how to write the domain? Parentheses, negative infinity, comma, 2, bracket. That will be your domain. Correct? I did like 3, 4 examples for you to explain how to deal or how to find the domain of polynomial functions, rational functions, and square root functions. Next topic that I want to discuss with you after we learn the domain, correct? Algebra of functions. The algebra of functions. The name looks really difficult. Whoa, what is the algebra of functions? But as soon as I explain for you, you will start laughing because it's really easy and you already know this, but not by this name. What is algebra of functions? Algebra of functions means the 4 operations that we have in mathematics. Sum, difference, product, and quotient, correct? We call this 4 operation algebra. Algebra of functions, it means adding functions with each other, finding the difference between two functions, or I can say in a simple language, subtraction of functions. Product, it means multiply two functions, which you already know how to multiply algebraic expressions, and also dividing functions. Let's start. You have 4 operations. Number 1, sum. If I have f plus g of x, you have 2 functions. One of them is f of x. The other one is what? G of x. If you want to add these 2 functions, then f plus g of x means f of x plus g of x. Correct? Before jumping to the second one, let's do a few examples, then go to the second one. In your book, they put all of them first in a table, then they do examples. But let me explain here first few examples, then I'll jump to the next one, correct? Example number 1. For example, f of x equals 2x plus 5, and g of x is given to you as a 3x squared minus 7x plus 2. They are asking you in this example, find f plus g. In some books, they give you like all of it, find x plus g of x. In some books, they do this only, find f plus g. But it's better to write this way, find f plus g of x, correct? No problem, it's really easy. To be honest, on the test day, if I bring one of these problems for you, it's kind of free points for you. You will do this problem in a second, right? I know that f plus g of x means f of x plus what? G of x. Okay, replace the values. What is f of x? What's the value of f of x? The value of f of x is 2x plus 5. I'll recommend that in this step, please use parentheses. I know you don't need it for addition, but it's good to use because soon in the next one you will see you need parentheses, correct? Plus, what is the value of g of x? The value of g of x is 3x squared minus 7x plus 2. 3x squared minus 7x plus 2. And next step, remove the parentheses. 2x plus 5 plus 3x, or distribute the sign, right? But you know, when you are distributing a positive sign to a parenthesis, the signs inside the parentheses will not change, right? It stays the same. 3x squared minus 7x plus 2. Now, look here, I told you, you know it from way early when you start algebra, you know how to add two algebraic expressions, right? It's really easy. You are just combining what? Like terms. I have 3x squared here. I don't have any more x squared. I'll copy my 3x squared here. I have positive 2x here, negative 7x here. It gives me negative 5x. I have positive 5 and positive 2. It gives me positive 7. That's my f plus g. Easy? We're just adding algebraic expressions. Correct? Number 2. Rule number 2, or operation number 2, difference. You want to find the difference, correct? Formula, if you're looking for the f minus g of x, it's the same as addition. Means f of x minus g of x. That's it. Example. F of x equals 2x minus 1. I'll copy this example from your book. And g of x equals x squared plus x minus 2. X squared plus x minus 2. Find f minus g of x. Correct? f minus g of x means f of x minus what? G of x. Replace the value. What is the value of f of x? The value of f of x is 2x minus 1. 2x minus 1. I'll use parentheses. Then what is the sign? The sign in between is negative. I'll open another parenthesis. What is the value of g of x? G of x is x squared plus x minus 2. Now, here, your parentheses is really important because look, if I don't use parentheses here for the second function, if I do by mistake somehow, if I write like this negative will be only belong to x squared, correct? When you are using parentheses, you distribute the negative to all terms. You see, all the signs inside the parentheses will change. If you do such a mistake on the test, then don't kind of say, oh, it was a small mistake. No, it's not a small mistake. That your answer will be totally, totally different than what the correct answer is, correct? Focus always. Now, I can say f minus g of x equals, remove the first parentheses to x minus 1, distribute the negative minus x squared minus x plus 2, correct? Now combine like terms. F minus g of x equals negative x squared, because I don't have any more x squared, I'll copy it. Positive 2x, negative x gives you positive x. Negative 1, positive 2 gives you 1. Correct? That's your final answer. Number 3. Product. If someone is asking you this, f times g of x. Be careful. I know some of students, they do this, they try to put really a good sign, like multiply. If by mistake you do this, you put here like a little circle like this is something else that soon we will discuss. It's not f times g. We read this one f of g. Soon we will discuss that, correct? Even you don't need this sign. We can write fg of x. It means multiply, right? It's easy. Fg of x equals f of x times g of x. That's it. Let's do a numeric example. Same example. F of x, f of x equals, let's say, let me do another example, not the one in your book, a different one. F of x equals 2x minus 1. Oops, why parentheses? And g of x equals x squared minus 5x plus 2. Find f times g of x. Correct? Now, f times g of x equals f of x times g of x. Correct? Replace the values. Your f of x is 2x minus 1. Your g of x is x squared minus 5x plus 2. You know you're doing here, you distribute the first term to all, then you distribute the second term to all, right? Distribute first 2x to all of them like this, then distribute -1, correct? Then it's equal 2x times x squared gives you 2x cubed. Positive times negative gives you negative. 2 times 5 gives you 10. X times x gives you x squared. Positive times positive gives you positive. 2x times 2 gives you 4x. Now distribute the second term like this. -1 times x squared gives you negative x squared. -1 times -5 gives you positive 5 and x, correct? -1 times positive 2 gives you -2. Now what you do? Combine like terms. Last step. If you have 2x cubed, I have -10x squared here, -x squared here, it becomes -11x squared. I have positive 4x here, positive 5x there, it gives me positive 9x, correct? And minus 2. That's it, you are done. This is f times g. Last one, number 4, quotient. This pen killing quotient. If you have f over g of x, it means f of x over what? G of x. That's the rule. Example. F of x equals x squared plus 7x plus 10, and g of x equals x plus 5. Find f over g of x. Correct? And also find this one. And maybe I'll ask this one also. G of x, g over f of x. They can ask you this also. Not always f over g. We can do g over f also, whatever they are asking us, correct? Let's do both. F over g of x equals f of x over g of x. Replace the values. What is my f of x? X squared plus 7x plus 10. What is my g of x? X plus 5. If you can factor and simplify, please factor and simplify. But if you cannot, that's your answer. But here you see we can factor the top. What are the factors of the top? The factors of the top is x plus 5 and x plus 2 and over x plus 5. Here you see you can cancel out x plus 5 with x plus 5. Then your final answer will be what? X plus 2. G over f of x. If I'm good enough in algebra, Immediately I will write my answer is 1 over, because here you have x plus 2, correct? Actually, your denominator is 1. If I'm good in algebra, immediately I will write my answer. It's 1 over x plus 2. If not, do the same thing, but please write the f of x in the denominator, g of x in the numerator, and you will see you will end up with 1 over, correct? This was all about algebra of the functions. I told you the name looks different, but actually you studied this even from the second day when you start algebra, right? Dealing with algebraic expressions, adding, subtraction, multiplying, and dividing algebraic expressions. Our next important topic is composite function. I will explain composite functions for you. Then after that, we talk a little bit about the domain of those functions, correct? As you see in the topic, now we are discussing here composite functions, correct? My handwriting is not this bad. Believe me, if I use a whiteboard here, I'm using a Vacom to write for you. And the pen for Vacom is kind of moving so fast on the Vacom, and I have no control on my writing. And my Wacom is like maybe 5" by 6". And I have a little small surface to write on it. That's why my handwriting goes like this. Anyway, I have a bad writing in general. Composite functions. What is the composition of two functions? In a very simple language. For example, if you have two functions, one of them f of x and the other one is g of x. Composition means you plug in one function inside the other function, like this. For example, bringing g inside x, correct? We call that one composition of functions. And the notation is f, a little circle like this, and g, or g, a little circle, then f. We read f of g of whatever your variable is, x, correct? F of g of x means f, you see here, you can see when I draw this line. When I draw this line, it makes it easy. Bring inside x that function, plug it inside. F of g of x. We call this one composition of functions. G of f of x means g parentheses, like if you plug like this, you plug f in g, right? Then g parentheses f of x, like this. To explain it more in a better language, in a diagram, there is a beautiful diagram in your book on page 306. Think this way, you have two machines here. Correct? One, and you have here another one. The first machine is function g. The second machine is your function f. You plug in a value here, plug in x here. Of course, when it comes out, it gives you what? G of x, right? You plug in x and g. And you plug g to the f. Of course, it gives you f of g of what? X. That will be the, if I want to show it in a diagram for you, how it works, composition works, correct? This is composition. I know some of you that you studied this topic before, it was looking difficult for you, maybe some of you, I don't know. I'm not inside the class to ask you. The only way that we can explain is this way. It's not difficult. Even when I start solving problems for you, I'll show you another trick there, which makes it really, really easy. Somehow my camera is not working today. I don't know what happened to my camera, but I know my camera is not working. Other than that, I could show even this diagram with my hands to you. But I'm trying, I'm clicking on my camera, but it's not working. Something happened bad to my computer maybe today. Even I cannot turn on my camera. It's not working. Okay, no problem. Let's do a few examples. Even before examples, let's talk a little bit about the domain. The domain of composite functions for example, f of g, correct, is the set of all x's, is the set of all x such that number one, x is in the domain of G and number two, G of x is in the domain of F. Of F. This definition, how to find the domain, please remember, because sometimes when you deal with composite functions, if I give you a square root or a rational functions, you have to think about restrictions also, right? Whatever restriction you have in G, or if G is a restriction for F, you have to remove that restriction from the domain, correct? This is the explanation here that I put for you. Now, let's do example. Example number one. F of x equals 3x minus 4 and g of x. Let's start with easy ones. And g of x equals, let's say, for example, x plus 5. Find f of g of x and g of f of x. Correct? Focus here in this example. You will learn hopefully how to do the composition. Correct? A. I will find first f of g of x. F of g of x means f parentheses g of x. If I read, it means whatever my g of x is, I have to plug it in f. How? Let me show you here. My function f is, let me rewrite the functions to make it easier for you. Look, you don't need to go this way, but learn it this way, correct? Look, your f of x is, let me go a little bit more down. Your f of, oh my God, your f of x is 3x minus 4, right? Your g of x is x plus 5. F of g means, focus here, plug in g and the f. It means here you are looking for the f of x plus 5. And you know how to deal with f of x plus 5. Whatever, wherever you have x on the left side, you replace it with what? With x plus 5 like this. Then this side will be 3 times, I'll change x with what? X plus 5. And minus 4. Now simplify this. This is your f of g. Distribute 3 to both. It gives you 3x plus 15 minus 4, which gives you 3x plus 11. This is your f of g of x. Hopefully you understand, right? I just show it for you how f, bring g and plug it in what? In f. Now, the other one, b, g of f. b, g of f of x means g parentheses f of x. It means plug in f of x in g. What is my g? What is function g? Function g of x is equal what? What was that? X plus 5? X plus 5. Correct? F of x was what? 2x something? 3x minus 4. Look the other way, the easy way. Plug in f in g. It means take this one, plug it here instead of x. This is what you do actually. Easy way. I explain it in 2 different ways, correct? Which way is easier for you? Then fg of f of x equals, replace x with what? 3x minus 4. 3x minus 4 plus 5, which gives you 3x plus 1. That's it. This is the composition of functions, correct? I ask you, what is the domain of this function? The domain of g of f of x. What is the domain of this function? Do you have restriction in both of them? No, both of them was polynomial functions, correct? Then the domain will be from negative infinity to positive infinity because there was no restriction. Both of them was polynomial functions, correct? This is all about section 2.6. Let me discuss something with you before I stop the lecture. Not a newer class. One of my calculus students, which is, I have another class of calculus, one day sent me an email and mentioned, sir, there are problems that in my homework that it was not in the lecture. Lecture, usually, we give you the concept of that topic, right? Examples can be different, right? There are thousands of different examples. We cannot cover all those examples here, all types of it for you, correct? Try to learn the concept. Then whatever the problem is, it will be easy for you to deal with. If not, please come online in my office hours. I said, sir, it's not matching the lecture, or it's not, I didn't learn the concept, or it's not matching. I will explain it to you, correct? I'll explain it to you. But why I mentioned this, because I cannot do a lot of examples. You think if I do like 20 or 50 examples in each lecture, how long it will take? Each lecture will be 5 hours or 3 hours, correct? That's why I'm assigning homework for you to practice with, correct? Anyway, this was all about your section 2.6. I'll stop the lecture here and see you next time in section 2.7.